All right, so we're going to look at the 11.7 homework now. I think I'm going to do 5 questions for this video, and then I'll do a second video for the second time. All right, so number 1 isn't intended to be difficult, but sometimes the easy questions are the ones that are the most trickiest. So here we have a hurricane that hits a year, I guess the probability that a hurricane will hit Victor is 0.10, which is a number between 0 and 1. Question is, what is the probability that a hurricane will hit 5 years in a row? So these are independent events. In this section, since we are talking about independent and dependent, I don't know, I think we should remember the difference there. So these are independent events, meaning that each year is independent of the next. So the probability, I'm going to do it this way with blanks. So year 1, year 2, year 3, year 4, year 5. 5 years in a row. So the probability for each year is 0.10. Okay. So year 1 is 0.10. Year 2 is 0.10. Year 3, etc., etc. So if we multiply these together, I'm going to show you a couple of things we're going to do. 0.10 times 0.10, it's 2 of them. Now I have to keep track of how many of these 0.10s I've got. There should be 5. So the probability is 0.00001. So 0.0001. That's one thing I could do. If you recognize that it's 0.1 times 0.1 times 0.1, I could do 0.10 raised to the 5th, because there's 1, 2, 3, 4, 5. So I could do that. So watch, 0.10. The raise button is this caret. I think we've talked about it before. To the 5th, and I get the same thing. 0.0004 of those zeros and a 1. And that button is a caret. If I want to raise something, it's a caret button. All right, so that's the first one. Not too difficult, but sometimes those first questions can be a little tricky. All right. Now, we're going to do number 8. On my paper, I had to print these off very quickly on campus. So these actually I didn't get a chance to do the color, but you can kind of read these. This is purple where it's at right now. So it wants to know yellow, which are the obvious ones, then blue, and then purple. So what I'm going to do is I'm going to kind of draw something to remind us what. So this is yellow, and this is yellow. Blue, then purple. So those are the ones that are hard to see. This is blue, this is blue, this is purple. I'm not sure what that one is. I'll have to see. That one might be blue. Okay. So let's just see what we get here. All right, so again, I might look and see what that one is. Okay, so yellow, then blue, then purple. So these are also independent events because we're going to spin a spinner. Independent. Each time I spin that spinner, it's independent. So that means we're going to multiply each of these probabilities together. I'm going to do it this way. First spin, second spin, third spin. So the probability of the first thing, which is yellow, there's two yellows, that's going to be 2 over, let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 options. Now I can reduce this, but I don't know if I want to yet. Then the next one is blue. So this is the one we might have to change because this corner here may be blue, but I'm not sure. But for sure, these two guys are blue. So for now, I'm going to put 2, and then it's a total of 1, 2, 3, 4, 5, 6, 7, 8. So a total of 8 possibilities. And then the third one is purple. Okay, this is the one that I know is purple, so I'm going to put 1, because I only count one of them, and there's 8 possibilities. So let's see what happens. All right, so I'm typing this in. Yep, so on this one, this guy here, which I couldn't read online, and you're probably not going to be able to read on yours, so I'm sorry about that. This one on my paper is actually blue, so this is going to be 3. On my math lab, it's a little more clear. So here's what we're going to do. We're going to multiply these. I can do this a couple of ways. I could multiply each of these with parentheses. So I could be extra careful. I can do 2 divided by 8. Open more parentheses. It's understood that it's multiplication. 3 divided by 8. And then 1 divided by 8. And I get a decimal. But remember, I can fix that decimal by second PRB, and I get 356. Now that's one thing. I could do the following. I could multiply the top, okay? You could do this, 2 over 8 times 3 over 8 times 1 over 8. I could say, all right, what's 2 times 3 times 1? Obviously, 6. Now the one I don't necessarily know is 8 times 8 times 8, but I can do 8 times 8 times 8. I get 512. So I could do a second step and say, well, what's 6 divided by 512? Calculator gives me a decimal, second PRB, 3 over 56. You will find what works for you. Oops. The best thing to do is be familiar with your calculator. Okay. Use down here. A single die is rolled twice. That is the same as rolling 2 dice once. But here, single die twice. Find the probability of rolling an even number first, and then a number greater than 3 the second time. Number 11. If I roll a single die twice, if I roll 2 die once, same thing. These are also independent. So kind of just be aware of what independent versus dependent. Independent meaning the first thing doesn't affect the second. Okay, probability of rolling an even number. Since these are independent, I could have done these on the first two. I suppose I should show you the formula. So even number and greater than 3. Okay, so just to backtrack, you're going to find these formulas, you don't have to use them precisely every time because we're just doing this times this. So if I want to show the formula, these are independent, which means it's going to be probability of an even number times the probability of greater than 3. Okay, and that is exactly what is happening in this work right here. When I work it out, that's what I'm doing. This will be the probability of an even. Let's see if I got room. I'll put it right. Even number. This will be greater than 3. And you'll probably work it more similar to this as well. All right, so if I roll a single dice, my sample space, 1, 2, 3, 4, 5, 6. If I roll a single die, then my even numbers are 2, 4, 6. So the probability of rolling an even number is 3 over 6. And then the probability of rolling something greater than 3 is also 3 over 6. Okay, I'm just kind of drawing some lines over my numbers. I could write that out again. So 3 over 6 times 3 over 6. Some books, some suggestions would say to reduce the fractions. You know what? I could say, well, 3/6 is 1/2 times 1/2. That's easy to see that it's a 4. But what if you don't want to reduce the fraction? What if you're rebellious? So let's do 3/6 times 3/6, and just let the calculator figure it out. 3 divided by 6 times 3 divided by 6. Second PRB, 1/4. So that would give you 9/36, which would. Okay, so again, that you find what's the easiest and most consistent way to work. All right. Number 12. Okay. Do this one and one more, and then I'll end the video. You draw a deck, draw a card from a deck of 52. Anytime they say that, in a standard deck. Then the card is replaced and the deck is shuffled. So this is with replacement. With replacement means independent, because it's like I'm drawing a card twice. I'm drawing a card, shuffling it, putting it back, shuffling it, drawing another. So with replacement means independent. I'm going to use my blanks again because most of us will. So probability of drawing a 7. A 7. The first time in a club, the second time. All right. So the probability of drawing a 7, remember there are 4 7s in a standard deck. In a club, there are 13 clubs. let's see, if I type this in, again, I could reduce this, right? I can make that 1 over 52, and that would be like 4 over 13. I'd say that would be 1 over 13. This would be 4. I could reduce them. I could just type them in. So, since most of you will probably type these in, I'm just going to type it. 4 divided by 52. Let's see if you can see that. Times, open parentheses, 13 divided by 52. Ugly decimal, second PRB. Okay. And then let's do one more. And then we'll do another video. Number 15 says, what's the probability of obtaining 3 tails in a row when flipping a coin? 3 tails in a row when flipping a coin. Kind of similar to the one with just one coin, but I guess first we got to think about, are these independent or dependent? If I flip a coin and then I flip a coin again, does the second time determine, does the first time determine what happens on the second or the third one? It doesn't. Each coin flip is independent. So we call this dependent, which means we're going to find the probability of each and just multiply them together. Okay. So the probability of 3 tails in a row, I'm going to write it out this way just to show you a difference, is the probability of tails, tails, tails. So tails and tails and tails. Okay. Since these are independent, it's going to be the probability of tails times the probability of tails times the probability of tails. The probability of tails, if I flip a coin, the sample space for flipping a coin is either heads or tails. Okay, so it's 50%. So 1/2 times 1 times. And if I look at this and I do 1/2 times 1/2 times 1/2, that's 1/8. But look, if you wanted to type it in, I could do, let's see where you can see it. I can do 1 divided by 2 times 1 divided by 2 times 1 divided by 2. That's a lot to type in, but I could do it, fix that, second PRV, 1/8. I could also do, since it's the same thing, I could do 1/2 raised to the 3rd with my caret. I mean, I could write it this way, but I would end up typing in 1 divided by 2 caret 3. And I got to put that in parentheses. So I'll show you that. 1 divided by 2, I'm going to raise it all of that to the 3rd. Fix that decimal. Okay. So